David Smith here with one more Flipped Classroom math video. Before we get started, I want to let you know that this is my 100th YouTube video. Woohoo! So a big thanks to everybody for watching, for liking, and for subscribing. I wouldn't have a YouTube channel without you guys, so thank you so much. Now before we start, remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point and catch up with your notes. Finally, you can turn on the captions so you can read my words go by on your screen. Today's topic, conditional probability. So this is another way of looking at probability. We're going to formalize our understanding of that. You've already been doing some conditional probability with your probability trees, you just haven't known it. So let's take a look. This is going to answer this question. What is the probability of a second event given the occurrence of a first event? So it's a little bit of a more delicate slice of probability. And to get started, we have some notation. So if A and B are two events, then PA, it's not quite a slash, that's a vertical line. So PAB means, what is the probability of A given that B has happened? Okay, so that's our definition of what we call conditional probability. So again, P vertical line B, or PA vertical line B, means what is the probability of A given that B happened? You're going to need to know this notation because a test or a quiz question might show up that's going to ask you something like that, and if you don't know what that means, you probably won't get it right. Okay, let's do an example. And I'm going to use a Venn diagram for this situation. You should be getting comfortable with your Venn diagrams. So I've got 25 students total. 15 of them like milk, 17 of them like coffee, 2 like neither, and 9 like both. So again, the first step with your Venn is to add whatever you can of these numbers to the diagram and then use a little math to figure out what the other numbers are. So like both, that's easy. That has to be right here. Like neither, we put that outside, so that would be there. And then 25 students, we put that up here. So that's what we can enter directly. Now we have to calculate what goes in here. This is the milk only, right? So 9 of the people that like milk are in here because they also like coffee. But we need to figure out what like milk only, and we can do that pretty simply. There's 15 total that like milk. 9 of those 15 also like coffee, so that leaves 6 for milk only. So now we need to do the same thing for like coffee, and we need to get the coffee only people. 17 of those people are here because they also like milk. So 17 minus the 9 that also like milk leave us with 8 for like coffee. Now let's check to make sure we filled in those correctly. We know we have 25 students, so all 4 of these numbers should add up to 25. Give that a quick check. I get 17 plus 6 is 23, plus 2 is 25, so we're good to go. Okay, let's do a few examples. I left our Venn diagram up here because that's really all we need to answer these questions. Now the first one is, what's the probability that they like milk? This is not conditional, this is just a straightforward question. You've answered these before. Second one is, what's the probability that they like milk given that they like coffee? And then we're going to reverse that for our third question. What's the probability they like coffee given that they like milk? Now if you'd like to pause the video now and see if you can get those right, go ahead and do that. Okay, so let's do probability that they like milk. So that's just out of the whole picture. So how many do we have? In the milk, we've got 6 and 9, so we got 15 people like milk. That's 15 out of 25, which is going to be 3 over 5. So that's the probability they like milk. So that's kind of a little bit of a warm-up. Now let's take a look at this conditional one. What's the probability that they like milk given that they like coffee? So we need to figure out what goes on the bottom of that fraction. Given that they like coffee means it's only the coffee people. That's our condition. So we're not looking at the total group here, we're just looking at the people that like coffee. So that's 17, right? Because I have 9 plus 8 in the coffee circle. So there's 17 people that like coffee. What's the probability that they like milk? That would be this 9 on top. Okay? So that's the probability that they like milk given that they like coffee. If you didn't already do this one, try that. Okay, so now it's probability that they like coffee given that they like milk. So the bottom is all the milk likers, and that's 6 and 9, so that's 15. And then the top is the probability that they like coffee, which would be 9. This one reduces nice and easily to 3 over 5. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.